Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So example 40, and this is still on the applications, the last application of the dot product. A 10 kilonewton vertical force is applied at point B on the surface shown. Determine the magnitude of the tension force produced by this force with respect to the tangent to the surface at point B. Then write the tension force as a vector with respect to the XYZ reference frame shown. So this is the X, the Y, and the Z. We have a hemisphere. This is the force, 10 kilonewtons, and it is located at B. This is 45 degrees. So the tangent at B will also form 45 degrees. So therefore, the magnitude of the component is 10 cosine of 45 degrees. Then that's the normal or tangential component. Then we resolve that into components. So that's the normal axis. Remember, this is 45 degrees also. So T is 10K in vector form because it is directed up parallel to the z-axis and with a magnitude of 10 kilonewtons. Then we define the unit vector along the normal axis. So lambda normal x is, we first compute this component which is negative, the magnitude is 1. The x component is negative because it is directed backward. So negative 1 cosine 45 is this component on the xy plane. Then times, because this is 60, so times cosine of 60. So times cosine 60. That's the x component of the unit vector along the normal axis. So it is equal to negative square root of 2 over 4. Lambda ny, it is also negative in that direction. So negative 1 cosine 45, then sine of 60. This component to the left. So lambda ny is negative quantity 1 cosine 45 times sine of 60 degrees. Simplifying, lambda ny is equal to negative square root of 6 over 4. Then the z component is just 1 upward, so positive 1 cosine of 45 or 1 sine 45. That's the same because sine and cosine are the same. So lambda nz is square root of 2 over 2. Therefore, in vector form, the unit vector is quantity negative square root of 2 over 4i, negative square root of 6 over 4j, and positive square root of 2 over 2k. We then obtain the dot product of this tension force with that unit vector to obtain the component of this force along the normal axis, or the component of the force along the normal axis. So that's the magnitude. Rn is that product of T with the normal unit vector. And it is 10 times square root of 2 over 2. So 5 square root of 2, the magnitude. Then to change this to vector form, we multiply this magnitude with this unit vector also. So R sub n in vector form is 5 square root of 2 times negative square root of 2 over 4i, negative square root of 6 over 4j, positive square root of 2 over 2k. Expanding, so R sub n in vector form is negative 2.500i minus 4.33j plus 5.00k kilonewtons. So that's it. Then for your part, this is the figure. We have a conical right circular cone, and point B is at h over 2, and h is 1.5 of r, the radius of the base. And this angle is 65 degrees, so you have to compute for the angle here or this angle, so that you can you can express the unit vector of the normal, which is along the surface here, this green one, and solve the problem. And show that R sub n in vector form is negative 1.951i minus 4.183j plus 6.923k. So that's it for your part.